The beautiful mitzvah of Tekhelet was loved and revered by the Jews, but this was not enough to overcome the travails of history, and some 1300 years ago the knowledge of its preparation, and even the identification of the sea snail, the chilazon, source of the dye, slipped into obscurity. As the focus of Jewish life moved farther away from the northern coast of Israel, the center of the ancient Tekhelet dyeing industry, many lost hope that the beautiful mitzvah might ever be restored, save by miraculous divine intervention. But not everyone shared this view. In modern times, scholars, both secular and Jewish, began to study the topic, searching for clues that could help shed light on the ancient blue and purple dyes. Most notable of these were Rav Gershon Henoch Leiner of Radzin and Rav Yitzchak Isaac Halevi Herzog, chief rabbi of Ireland, who would eventually become the first chief rabbi of the State of Israel. In 1914, Rabbi Herzog completed a doctorate, collecting essentially all knowledge that was currently available on Tekhelet. As archaeological and historical evidence began to mount, pointing towards the Murex trunculus sea snail as the chilazon, the great modern mystery surrounding the attempt at rediscovering Tekhelet began to take shape. There were three statements that people believed to be true. 1. The Murex trunculus is the chilazon, the source of the Tekhelet dye. 2. Murex snails produced a beautiful purple dye. 3. Tekhelet is blue. Those three statements cannot all be true. Secular scholars maintain that the third statement was false, namely that Jewish tradition was mistaken and Tekhelet must have been purple. The Radziner Rebbe railed against that opinion and warns his students not to, quote, fall into the trap set by the non-Jewish scholars who care not for the Jewish tradition and whose research and knowledge have led them to believe that its color, Tekhelet's color, is purple. And so he rejected the first statement and searched for an alternative candidate for the chilazon other than a sea snail. Rav Herzog did not accept the Radziner's approach and remained confused. On the one hand, he found the evidence from archaeology convincing. That the murex was used for dyeing in the ancient world was an incontrovertible fact. He also respected the scientists who were telling him that the murex could only dye purple. But he was simply not willing to dismiss the deeply held Jewish tradition so emphatically stated in both Midrash as well as Halacha that Tekhelet was sky blue. Even though the topic was dear to him throughout his life, Rav Herzog died in 1959 with a mystery still in place. The chilazon was most probably the murex, but murex snails give a purple dye, and Tekhelet is blue. Before we can attempt to solve this mystery, we need to look at how exactly one dyes with the snail altogether. The first stage in the dyeing process is to extract the glands that store the dye from the Murex trunculus sea snail by breaking open the shells and extracting the glands one by one. Then we dry them and grind them into a powder. Next we add hot water. You can see that even after stirring the mixture, the powdered glands sink to the bottom and the water stays completely clear, because the dye molecules are not water-soluble. This is what we should expect from a good fast dye, since we don't want the color to wash out. But it poses a major problem, since if the dye won't bond to water, how can we attach it to the wool fibers? We need to trick it chemically, first to get it to dissolve in water, then embed it in the wool, and finally return it to its inert state so it will never wash out. We do this by adding a very strong base, caustic soda. This has two effects. It helps dissolve some of the fats and proteins that are unwanted byproducts we get from the snail. The second and main purpose is to set the pH so that the next chemical can work. This chemical is the most important one, sodium dithionite. It's a very strong reducing agent and allows the dye to bond with water. As you can see, the color of the vat mixture now changes. It's not the blue Tekhelet that we want, but at least we can see that something is dissolving in the water. Before we can add the wool, we need to neutralize the solution a bit by adding a mild acid, citric acid will do, so as not to damage the wool. Adding this chemical generates an overpowering odor. No wonder it was forbidden to dye in Yerushalayim because of the smell. But as it happens, if it weren't for the incredibly horrible smell, we might never have discovered the secret of Tekhelet in modern times. We're now ready to add the wool, and from this stage moving forward, every act has to be done with the proper kavanah, with the express purpose of fulfilling the mitzvah of tzitzit. And so we will now say, L'shem mitzvah tzitzit. We will now leave the dye in the sun for reasons that will become apparent shortly, and return to the mystery of Tekhelet that we spoke of earlier. The solution to the problem of murex dyes producing only purple was solved in 1985, when a crucial piece of information became available. Professor Otto Elsner, an Israeli chemist at the Shenkar College of Fibers, who had been a dye chemist in Poland before the war, began to research the murex snails and their dyes. Since the dye process results in an overwhelming stench, as we mentioned, and something that the Talmud already notes, Elsner took his work outside to the fresh air. He followed the standard process, broke open the snails, took out the dye glands, and put them in a vat with the chemicals needed to get them to dissolve in water in order to dye wool. When he removed the wool, it turned purple, just like everyone before him. But that was only on cloudy days. When he did the dyeing in bright sunlight, the color of the wool was a beautiful sky blue. Elsner had discovered that exposing the dye to sunlight at a very specific point in the dyeing process changes the purple components into blue. Let's take a look more closely at the chemistry behind Elsner's discovery. There are 3 molecules that the murex snail produces. The first is indigo, which has a blue color. There are also 2 more molecules, an indigo base with 1 or 2 bromine atoms attached. Those are called monobromoindigo and dibromoindigo, and they have purple colors. If you dye wool in a mixture of all 3 of these molecules, and that's the way the secretion comes out of the snail, you get purple. In order to get any of these molecules to become soluble in water, that is, in order to enable them to dye wool, they need to undergo a process called reduction. The chemicals that were added to the solution were meant to do exactly that. In the reduced states, the molecules change color to yellow-green. Elsner found that during this phase, exposing the molecules that had bromine attached, mono or dibromoindigo, to the radiation of sunlight breaks the bonds between the indigo base and its attached bromine atoms. What is left is indigo, or almost indigo. The molecule still is in its reduced state, and in order to fix it strongly to the wool so that it will never wash out, it needs to be taken out of reduction, a process called oxidation. At that point it returns to its proper color, not purple, but the beautiful blue of Tekhelet, similar to the sea and similar to the sky. The effects of sunlight would most certainly have been noticed by the ancient dyers, since they did all their work on the shores of the sea under the bright Mediterranean sun. At this point, we are ready to take the wool out of the dye solution and expose it to the air where it will undergo oxidation. The transformation of the dye mixture due to sunlight has already taken place. As you can see, the wool slowly changes color to the beautiful sky blue that our tradition had always maintained. The color of Tekhelet dyed wool is, as the Rambam states, the color of the clear sky as it appears to the eye. Murex dyes are also among the most color-fast natural dyes known. Again, as the Rambam states, it remains steadfast in its beauty and will never change. With the rediscovery of Tekhelet, of its source, the chilazon, and of the process required to dye wool, perhaps we can paraphrase the Midrash and be grateful to Hashem that now we no longer have only white, for Tekhelet has been found.